So now it's time to talk about a little bit about design in acoustics. Again, we are talking about the results from silent build. And part of those things that are presented here are coming from the silent timber build project. Oh, it's working. Okay. So, okay, first we have to talk about design and design. A building is a matter of design, of course. It's a matter of design about multi-criteria things that happen to the building. It is mechanics, it's thermal, it is fire, durability, etc., and also acoustics. And we can say that, well, Klaas was talking about that, everything in building design is calculated except acoustics. And this is not coming from the other people that don't trust our calculation, it's just our people that don't trust in their own calculation. So there is a work to do here, there is something to do, and we were working on that subject during the project Silent Timber Build. Voilà, voilà. Okay, here are some results are coming from other projects. FP 702 that was on lightweight construction. Bart and Klaas were talking about this. We can perform high-level characteristics, and wood is used for sustainability. It is used because it's easy to prefab, and actually in around 2007 we experienced a real change in our way of constructing, and this was, I call it, the green revolution for construction. And in that area wood was really used as a totem material. Everybody wanted wood for construction, and this is very good for us, especially when you work in the forestry. Okay, so of course we were talking about acoustics in the design stage. Of course it's essential to take into account a low frequency. Today it's not regulated, but in the future it will be, for sure, so it's a matter of research scientists there. And also we know that we can, with lightweight construction, we can perform high level of acoustics. So building with wood is a matter of also prefabrication. You have machines that could build the walls, the floors, and so on, prefab. And from one kind of build-ups, you can get a replication, and this is very easy for fabrication, but also for characterizing one type of build-ups. Okay, so this is our work in 20 years. Okay, the use of wood was more or less used for single houses, and for acoustics, it's about acoustics, huh? Single houses, acoustics. For a single house is only a matter of noise that's coming from outside, from a very small level and not urban area. So then in the mid of 2000 we started talking about multi-family houses and also terrace houses here. And now we're turning into making high-rise building. This is, of course, somebody is aware about I don't know what, because everything is under, everything is mastered, okay, under control. Voilà. So the design process. What is the design process? We start with a 2D level and then a 3D level. 2D level, our knowledge in the construction is about wall, floor. Everything is tested, and we just mix material and make an integration in 2 dimensions, okay? And from that 2-dimensional integration, we just also, with the use of the only method for integration in acoustic is the EN12354. And with the knowledge in junction, we can turn our model into a 3D. So from walls, you get the sound transmission loss and impact noise performance for floor. And from junction, you need to measure the vibration reduction indexes, the KIG and the VIG. And also, of course, the method is the one that is explained in the model that we call Gerritsen model, or 1, 2, 3, 5, 4. Okay? So, we were talking about series of type of construction. Here is the biggest problem in the industry for wood. From only one wall, let's work on how much kind of wall we can build. From one type, for one type of wall, you can choose different kind of structure. You can choose different kind of panels from one side and panels from other side. You can fill this one with fibrous elements. It can be glass wool, it can be rock wool, it can be wooden fibers, it can be cellulose and others. That wool can be coated with cladding for exterior, plasterboard from the interior. And also the junction inside the wall can be in different kind. It can be point connection, it is nailed. It can be separated structure, can be resilient, can be using resilient metallic resilient channel and other kind. So if you add and multiply all the configuration that you can get here, you can get a lot of kind of possibility of combination of wool. And this, if you are selling and opening this market to your clients, then you have to, for today, measure all the kind of performance of those walls, and this is of course not possible. So, what to do? So, of course, we copy the others. Huh? So we go to the people that are performing nice performance. I did it, of course. The bunker floor is copied. Sorry for that, but so we copy our competitors, not really, huh? Our friends, and then we can also make some trial and test. This is for, let's say, industry. Of course, this is risky. Other side is, let's see what are doing the scientists. They can also copy, no problem. But they are working on calculation method. And with those calculation methods, it will never work if we don't get any agreement in between our community, okay? And from that, we will get a new generation in construction. So let's see here a normal wall, let's say it's a prefab system, it can produce whatever on the surface, and from only one type of structure, he can get, I don't know how much system. And all of this has to be measured. So here is the lab, okay? Imagine if you have to try all those, then it's a really peplum, a lot of work. So, for instance, for an industrial person, we can just tell him, okay, you come, you measure a few one, and then from that, we will extend the performance with some characters, with some calculation modeling. We can extend your number of setups into a wider range, okay? And with our calculation method, we just calculate new performance from the measured one. So, measured, calculated, the difference in between, we set it as a reference, and then we calculate something that we didn't measure, and then apply the difference on top of it, and we get this kind of curves. And we give it to the person, and he's happy. So, what are the lessons learned from the past? Of course, this kind of approach in calculation is very nice for industry, and it opens capacity for being more competitive for industry, for wood industry. Okay, so the lesson learned is that acoustic is predominant as a design criteria. Of course, this we heard it more than one time today. Also, the acoustic design has to start same time at as all other criteria. You cannot build up you make every detail of your construction and say, okay, please now tell me that it's okay in acoustics. No, everything you do on a structure has an influence on acoustics, especially for mechanics, yeah? Junctions, inside the construction. You cannot decide from one day to the other, this is going to work in acoustics. It never worked, this one. Okay, so you'd have to invite an acoustician in your team, huh? Yes, and another thing very important is that the design tool have to be more accessible to the engineers. Today, it's very confidential. No? We want it to be democratic. Everybody can make calculation, and also with a little bit of training, the other acoustician will agree with him, and also we can make, confrontation between calculation and testing, and make it more easy for prediction. Okay, also part of things we cannot predict for the time being. We will work on that, maybe other projects in the future. How to predict junction, and this we still now have to measure it. Okay, and make database of measurement. So here's the picture of Bart. So now I win back my 4 bottles. No, 3 bottles. Bart, see, look at that. So we are focusing on energy. When you build, this is the bet that the people that when you say, okay, I'm building energy efficient things, if you build it, you save money, okay? And you save the planet. Oh, that's cool. First time you're stingy, and even you save the planet. Huh? It's incredible. Okay, and why not then? Why not? So we did it, and we are doing it very easily. Okay, no problem. And then if you ask an acoustician, okay, now I'm going to build acoustic efficient. So what I mean, is there any money I can win? Say, yeah, well, no. If you build acoustic efficient, then you will be more comfortable, and you will save your health. So yes, you will save money. Of course, you save your health. So the index on if we are only comparing things with money, then okay, energy is very easy to understand. Okay, but acoustics, of course, it's very important, and moreover, it's about your health. So what else can be more important than our life? And that's it. Thank you for your attention.